So now we're going to be doing a little bit more. If it's an exact value, we're going to know our exact values. If it's a calculator question, then we're going to go over how to do this on the calculator here. All right. So let's get started. 2 cos squared theta minus 1 equals 0. So first step, we would be moving the 1 over. So we get 2 cos squared theta equals 1. Divide by 2. We get cos squared theta equals 1 over 2. And then, of course, when we square root it, we get cos theta is equal to plus or minus the square root of 1/2, which if you don't recognize that is plus or minus 1 over root 2, which is the same thing as plus or minus root 2 over 2. So this is an exact value that is on the unit circle. Notice that this is in degrees, so you have to make sure that you're stating this in degrees. So can anybody tell me the reference angle for cos theta being root 2 over 2? So I'm going to do it as my reference angle. What family would be root 2 over 2?
45 degrees.
Yes, thank you. Okay, so when it's plus or minus, basically that's encompassing every single family in one revolution. So that means, therefore, theta would be 45, 135, 225, and 315 as my final answer. All right, any questions there? So the next one is 2 tan squared theta minus tan theta minus 1 equals 0. So if you're having a little bit of trouble factoring this, on a scrap piece of paper, you could use X to try to factor, but you should get used to factoring with the tan thetas in it. So again, if you solve by factoring, you are making sure you don't drop your equals 0, and you, if there is something on the other side where you don't have it equal to 0, make sure you move it over. So of course 2 is a prime, so I'm going to put 2 tan theta here and tan theta here, and 1 is, there's only a way you can do 1 is 1 and 1. So in order for us to get a negative middle term, the 2 would have to be, the 2 tan theta would have to be minus, and this would have to be plus. So just remembering that once I factor, the reason why solving by factoring works is the fact that the product is equal to 0, which means each individual factor is equal to 0. So 2 tan theta plus 1 equals 0, which means tan theta is equal to negative 1/2, and tan theta is equal to 1, right? Because tan theta minus 1 equals 0, so we move the 1 over. Okay, so on tan theta equal to 1, that is an exact value. So who can tell me, again, this is in radians this time, what reference angle is theta equal to 1?
45 degrees?
Yes, so because this is in radians, I'm going to do it as pi over 4. Okay, and so now we're going to go to the calculator, and tan theta equals negative 1/2 is not on the unit. So first off, make sure you go on your calculator and you check to make sure that in your mode that it's in radians, because this question's in radians, right? Okay, so that's the first thing. So I'm going to quit out of there. And then I am going to find a reference angle. Now remember that we do not use the actual sign negative. We're just going to go inverse tan of 1/2. So this will be our reference angle. Okay, so I'm going to just write that down. So my reference angle is 0.463 Okay, so now, because this is a calculator question and we cannot round before the final answer, you need to make sure that you store this. So I'm going to go over how to store this. Does everybody see the STO button here with an arrow? So you're going to store it, and then you pick a letter where you want to store it. I always like storing it in A, so I'm going to go store, and then I'm going to go alpha math, which gives me A. So do you see I've now stored that answer in A. Okay, any questions before I go on? Does anybody need me to do that again? Okay, so again, it's store and then alpha A. Okay, so now we got to think, where is tan theta negative? So if I look at oh, my pen is now dead. Give me 1 second. Kind of funny how it just magically just died. Okay, so what quadrants would tan be negative for this, for the decimals here? So remember our CAST rule? Yes, 2 and 4. So here and here is negative for tan. All right, so can anybody tell me what to do with this reference angle to get it into the second quadrant? What would I type into my calculator? How would I place it in to get this part right there?
Would you add half, or would you add half like pi over 2?
Nope, remember our reference angle is always with to the x-axis, so we'd be using pi or 2 pi reference, never pi over 2, right? So who can tell me what to do? So I guess what I'm trying to say is this little guy right here is the 0.4636. So how would I get the other way around, which is from 0 to that?
Take pi and subtract your reference angle.
Very good. Okay, so I'm going to do pi. And remember, I stored this, so I'm going to go subtract. And I stored it in A, so then I'm going to recall A. And I get 2 point, so I'm going to go there for. Theta is 2.6779. So I know it says correct to 3, but I always go 4. You can truncate it at 4, and that's what I do. You can round at 3, you can truncate at 3, but you can't go less than 3. So I always go 4 just to make sure. Okay, so I have that second quadrant answer. Now I need the fourth quadrant answer. So I need to go all the way around here. So again, this is my reference right there. So can anybody tell me how I would find that answer?
It'd be 2 pi minus the reference angle.
Yes. So, oops, I go 2 and then pi, subtract my reference angle, which was A. So then I get 5.81995. Okay, and then tan was 1 at pi over 4. And can anybody tell me the other quadrant where tan would be positive 1? So pi over 4 would be here. What is the pi over 4 family in the third quadrant?
Would it be 5 pi over 4?
It would be, thank you. Okay, so then there are all my answers. So I know in the past that students usually have trouble with the calculator part more than the non-calculator part. So, so yeah. Make sure you practice lots of the calculator questions as well. Okay, so now we're going to go on to C here. So 2 cos squared theta minus cos theta equals 0. Sometimes people have trouble factoring this, but it's just a GCF factor actually. So it's it is cos theta 2 cos theta minus 1 equals 0. again, once we factor it, that means cos theta equals 0, and 2 cos theta minus 1 equals 0, which means cos theta equals 1/2. So these are all answers that are exact values on the unit circle. Now notice that the answers are within a very severe domain restriction. Basically, it's saying that it's going from the second quadrant to the third quadrant only. So we only want answers in quadrant 2 and quadrant 3. Cos theta equals 0. Where is cos theta equal to 0? Anybody? Cos is my x. So where would x be 0?
Pi over 2 and 3 pi over 2.
Yes, and then just check to see that it's within the domain, and it does have equal signs here. So those two are absolutely correct. And then if we do our reference angle for cos equals 1/2, what would that be? Which family is cos 1/2?
Pi over 3.
Yes, pi over 3. So now, cos is positive in quadrant 1 and quadrant 4. So guess what? None of this attributes the answer there. So this is my only answers. Kind of weird, but they only wanted the answers in quadrant 2 and 3. So because cos theta is positive in quadrant 1 and 4, we can't list those answers, right? Okay, next up. Tan squared theta equals 6 plus tan theta. So I got to move everything over to the other side. So I got tan squared theta minus tan theta minus 6 equals 0. And this nicely factors. So tan theta would, in order to get a middle term of minus 1, it would be 3 and 2. And the 3 would have to be minus, and this would have to be plus. So tan theta equals -2, and tan theta equals 3. So these are not on the unit circle. So this is totally, it's not exact values on the unit circle. So we have to use our calculator to get this. So let's do tan theta is -2. So the first thing again is we're going to find a reference angle. So I'm just going to clear my calculator screen. And so I'm going to go inverse tan of 2. And I get 1.107. So I'm going to put this into my storage. So I'm storing it in alpha A. Okay, I'm storing it in alpha A. 1.1071. Okay, so then we got to think about where is tan negative? Which two quadrants are tan negative in one revolution of the circle?
I don't know if it's just.
Okay, let me know again if something happens. Okay. All right. So I have I inverse tan 2 to get my reference angle of 1.1071, and I stored it in A. So now, which two quadrants would tan be negative? Which two quadrants would tan be negative? Anybody?
2 and 4.
Yeah, 2 and 4. Very good. Okay, so then my next question is what am I going to do with this reference angle to get the answer in 2 and 4? How would I get this quadrant when my reference angle is right there? So what would I punch into my calculator? Would it be pi subtract the reference angle? So alpha A, so 2.03 3, 4, 4. Okay, and then to get the fourth
Miss
quadrant,
Ramsey.
does everybody see? Yeah.
Oh wait, never mind. It just showed up. It was just taking a while to show up while they were writing.
Okay. And then now we have 2 pi, and we have a reference angle right here. So I'm going to do 2 pi subtract my reference angle. So that would be 5.1760. All right. So now I still have to do tan theta equals 3. So I'm going to find my reference angle for that one. So this is going to be inverse tan of 3, and that is 1.2490. Okay, so I'm going to store that, and you don't have to store it in B, but just because I already had, this question had AUs, I'm going to store this reference angle in B, which is the alpha app there. Okay, so now tan is positive in which 2 quadrants here? Anybody want to tell me which tan is positive in which 2 quadrants?
1 and 3.
Yes, 1 and 3. Okay, so that means my reference angle is actually one of my answers, 1.2490. And then, did anybody remember the trick that I told you a while ago to get the second tan solution?
You would just add pi, would you not?
Yes, add pi. So actually I didn't even have to store that because it was my previous answer. So 4.3906. So there is my answers. All right. Okay, moving on. Let's go to E. So I got to move the 2 over. So sine squared theta minus sine theta minus 2 equals 0. And I'm going to factor that. So I'm going to give you a second to try to factor that. So sine theta and theta, and it looks like the only factors of 2 is 2 and 1. So then you just got to figure out, in order to get a middle term of minus, that means this would have to be minus. So that means sine theta equals -1 and sine theta equals 2. Does anybody remember the restrictions for sine theta and cosine theta? Does anybody remember the restrictions for
It has to be
the trig
equal to
ratios?
1 or lower.
Close, and I think you're saying what the answer is, but maybe you're just saying a little. I'm going to tie up the answer a little bit more. Both sine theta and cos theta have to be between 1 and -1. So if you have a trig ratio like this, that's bigger than 1, you would just automatically reject that because there is no way you can get a solution out of that. All right, so now we have sine theta equal to -1. Can anybody tell me where the y value is -1? Where's the y value on the unit circle -1?
Uh, 2 pi over 3, or 3 pi over 2, sorry.
Yeah, 3 pi over 2. Okay, so now if I look at my restrictions here, my restriction says they only want answers between 0 and pi. And the answer we just got was 3 pi over 2. So guess what? We reject that answer too, and we write no solutions possible, or you can just write no solution, it doesn't matter. Okay, now for the reciprocal functions. Does anybody remember what the reciprocal of secant is?
Cosine?
it cosine or sine? Yeah, it's cosine. Very good. Okay, so before we can solve this, we need to move the 6 over. So we get secant squared theta minus secant theta minus 6 equals 0. And we still have to factor it. We cannot change it into cos until we actually get what the trig ratio for secant is. So then we get secant theta and secant theta. And usually these are pretty easy to factor. So 3 and 2 to get a middle term of 1. So this has to be a minus, this has to be a plus. So that means secant theta equals 3 and secant theta equals -2, which means who can tell me what cos theta would equal? If secant theta is equal to 3, what would cos theta equal?
1/3.
Yep. And then what would cos theta equal over here? If secant theta is equal to
-1/2.
Cos theta, yes, -1/2. So at first class, you might think, oh, well, it's not possible because it's bigger than or less than -1. But then when you reciprocate it, you realize pretty quick that, oh, no, it's fine. It's only sine and cosine that have to be between those two. Okay, so cos theta equals 1/3 is a calculator question. It's not an exact value on the calculator, so I'm going to go inverse cos of 1 divided by 3. And I get 1.2. So I'm going to put my reference angle is 1.2309. Okay. And again, you can store this, but actually, because this is in 1 revolution of the circle, cos is positive in quadrant 1, which would be my reference angle, and quadrant 4. So then I'll say therefore, it is 1.2309. And then who can tell me how to get my 4th quadrant answer? What would I punch into my calculator?
2 pi subtract your reference angle.
2 pi subtract my reference angle, which is my previous answer. So I'm just going to use the previous answer key because I didn't store it. So 5.0522. Okay, so cos theta is equal to -1/2. So what family is cos theta equal to 1/2?
Pi/3.
Pi/3, very good. Okay, so then cos is negative in quadrant 2 and quadrant 3. So what are the pi/3s in quadrant 2?
Two pi/3.
Yeah. And then what's the pi/3 that's in the 3rd quadrant?
4 pi/3.
4 pi/3. Very good. All righty. Any questions before I go on? So it takes some practice, and especially the calculator, just knowing where you're supposed to be looking and things like that. Okay, example 2, we're going to get basically introduced to where day 3 is going for my solving. So example 2 says, solve the following in the stated interval. And then it says, then write the general solution. The general solution is for every rotation of the circle. Okay? So let's try this. All right, first step would be we need to factor this. So it doesn't look so obvious what the factor is, but it is only a GCF factor. So we're going to factor out a cotangent, and then we're left with 1 minus sine theta equals 0. So again, that means cotangent theta equals 0, and 1 minus sine theta equals 0, which if I move the sine theta over, you get that sine theta is equal to 1. All right, so where is cotangent theta equal to 0? Does anybody think they know? So cotangent, the reciprocal of tan. Remember, tan is, so instead of saying, instead of looking at it as the reciprocal of tan, what you can, the reciprocal of 0 is, of course, undefined. So then you could say, well, where is tan undefined? The other way you could look at this is cotangent is 0, where cos divided by sine is 0. So where would that happen? Does anybody know where tan is undefined?
Your y-axis.
Yeah, the y-axis, very good. Did you use the little trick I showed you before, or you just remember that?
I just remember that.
Okay, so pi over 2 and 3 pi over 2. And then where is sine theta equal to 1? It's actually at pi over 2 there. So I don't have to list it again. So I have now listed all the answers for A in the stated interval. For B, now what you're going to start getting used to is what's called the general solution. So the general solution means it's not just in one revolution of the circle, it's here, here, keep on going forever and ever and ever and ever and ever and ever and ever. Okay, so does everybody see if I start in this spot where I have my arrow, and then how much will it take of a revolution to get to the next spot?
Half a revolution?
Okay, and so half a revolution is measured in radians as?
Pi.
Pi. And then if I rotate pi again, do you see I keep on getting into those spots? So my general solution would then be pi over 2 plus k pi, where k is an element of the integers. Okay, so you got to get used to what k pi stands for. Again, k pi means every rotation of pi. 2k pi would be every full revolution. Okay, so again, this is just your first little introduction, but you'll slowly get used to this for sure. Okay, so next question is cosecant theta equals sine theta. So at first glance, it's like, well, there's nothing I can do here. However, cosecant theta is 1 over sine theta is equal to sine theta. So then I can do a quick cross multiply over so that I get 1 equals sine squared theta, which means sine theta equals plus or minus 1. So the y value is plus or minus 1 at exactly the last question's answer, which would be positive 1 at pi over 2 and negative 1 at 3 pi over 2. So theta equals pi over 2 and 3 pi over 2. So again, my answer, because it's in those spots and 180 degrees or pi from each other, it would be pi over 2. Sorry, I should be saying theta equals pi over 2 plus k pi. Again, because I'm introducing a k in there, I have to say that k is an element of the integers. My fancy little z there. Okay, so now we'll get into the next one. 3 sine squared x plus sine x equals 3. So I'm going to move the 3 over. So 3 sine squared x plus sine x minus 3 equals 0. And I'm going to try to factor this. So I try and I try and I try and I can't. So what does that mean? It means that we need to have another method to solve it. Does anybody know another method to solve a quadratic that doesn't involve factoring?
Completing the square?
Completing the square would be another method, but it's not probably my second choice. You like completing the square as your second choice? I'm just curious. What's the other choice?
Quadratic formula?
Yeah, the quadratic formula. So they've asked this in the past here. And just remember, the way I can tell if it's factorable or not is if b squared minus 4ac is a perfect square, then it's factorable. Okay? It is factorable. So just to check, I have a is b is 1 and c is negative 3. So b squared would be 1 squared minus 4 times 3 times negative 3. So this is 1 plus 36, which gives me 37. So definitely it was not factorable. I proved it there. However, now I could keep going. I already have the discriminant solved, so it's pretty easy to keep going. Now, remember when we do the quadratic formula, and again, this is on your formula sheet, the quadratic formula, it is in the form x equals. However, we're not doing x here, we're doing sine x equals. So that's one thing you need to practice. Don't skip any of the questions that you have to use the quadratic formula because it could be asked. So sine x equals minus b, so minus 1, plus or minus the discriminant in the square root, so I already figured that out, is 37, divided by 2a, which would be 6. Alrighty. So I'm going to punch this into my calculator here. All right, so does everybody see that I'm going to be doing the inverse sine of this? Okay, so first off, it's up to you if you want to do it in 2 steps or not. If you want, I'm going to show you the little trick. Because this whole thing is divided by 6, sometimes it's easier to go alpha y equals to get the fraction key, which is number 1. So then it's going to be minus 1. I'm going to go plus the square root of 37 over 6. And that is 0.847, blah, blah, blah. And you may want to store this in your calculator. Now, this is not the inverse. This is just what the representative of the right side is. So we're actually going to find the inverse sine of this. So inverse sine of the previous answer is my angle. So that's my reference angle. So XR would be 1.0105. Okay, so that's my reference. Okay, I'm going to store this now. I'm going to store this. I'm going to store this in alpha A. Okay. Now, if I go back and I do the quadratic formula, except this time I'm going to do subtract the root of 37. I'll show you a little trick so you don't have to punch it all in again. If you go second enter a couple times, oops, what am I doing? Oh my gosh, let's try that again. Second enter, second enter, second enter, second enter. Sometimes it's easier just to type it in again. So there it is. Okay. So now I can go back and go up. And then instead of the plus, I can just go subtract. And I get negative 0.18046. Now remember, sine theta has to be between -1 and +1. So that means I am actually going to be rejecting that negative part of it because it's too small of a ratio, right? So that means the second part of this quadratic formula is not going to attribute to, and that happens a lot of times where when you do the quadratic formula, one of them a lot of the times is too big. All right, so that means therefore x equals, now just going back to what my calculator said here, oh, you can't see it, but it was 0.8. When I took -1 and added the root of 37 over 6, it was 0.8 something. I can't see it on my calculator anymore, but anyways, actually I could probably do that again. just to show you that the trig ratio was positive, 0.847. So sine is positive in the first quadrant and the second quadrant. So that means one of my answers is going to be the reference angle, which is 1.0105. And then how do I find the second quadrant answer? That would be pi subtract my reference angle, which I entered was alpha A, so that's 2.1310. Okay, and that's my only answers that I get from this because the other ones did not work. Okay, so then that is my answer for A, which is the specific interval from 0 to 2 pi, and then B, the only way that I can get this spot and then this spot is it's not 90 degrees from each other at any means, even though it looks like it. The only way I can get 1.01 in every revolution is going all the way around again. So that means x equals 1.0105 plus 2k pi, which means every revolution. And same with the spot that's over here, 2.13, oops, 1310 plus 2k pi, where k is an element of the integers. Okay, again, I know this is getting a little bit more complicated. It will take some practice here. Okay, next one. 2 cos squared x minus 5 cos x minus 1 equals 0. If we try to factor it, we can't. And again, if you try b squared minus 4ac, I get a equals 2, b equals minus 5, and c equals minus 1. So I get negative 5 squared minus 4 times 2 times negative 1. So 25 plus 8 gives me 33. Definitely not factorable. 33 is not a perfect square. So I can keep going. So cos x is equal to minus b. So 5 plus or minus the square root of 33, because I already figured that out, that's why it's nice if you're not too sure if it's not factorable, just do the b squared minus 4ac. And then you're already halfway done the quadratic formula, right? So all over 2a, which is then 4. So if I punch this into my calculator, I'm just going to clear my screen here. So if I go, again, the little trick is alpha y equals, so that you can get the fraction key, and then it's a lot easier to type in. So 5 plus the square root of 33 over 4. So I get 2.686. So is that a legit cos trig ratio? 2.8686? No, right? It's bigger than 1. So in this case, I'm actually going to be canceling the plus this time. Okay, so I'm going to try this again. Go second enter, and go and make this a subtraction. And I get negative 0.18614. This is a legit one, okay? It's between negative 1 and 1. So now I can keep going. So now I'm going to be doing inverse cos. Now, as you can see, this inverse cos is negative, so you're going to have to watch because this will not give you the reference angle here. Okay, why? Because it's negative. So watch that, and it's too hard to make it positive, so I'm just going to do this. So 1.75 is giving me the answer in the second quadrant where cos is negative. Do you see that? The other quadrant where cos is negative is right here. So x equals 1.758. So this is the reason why I always tell you guys never to write never to inverse cos or inverse sine or inverse tan with a negative sign, because it does not give you the reference angle. So in order to find the second quadrant answer here it's a little bit, I don't know, complicated to say the least. Does everybody see my reference angle is actually that right there? And so this answer right here is 1.7580. So does anybody know how I could find the reference angle? Does anybody think they know how I could find the reference angle? So 1.7580 is the actual angle, but I need to
take pi and subtract that?
Yes, very good. So if I go pi and subtract my previous answer, I'll try that again. Pi, and I'm going to subtract my previous answer. I get 1.38 blah, blah, blah. So that means my reference angle is 1.3835. Okay. So now, I'm going to change my color here. How am I going to get this answer right here? What would I have to do with the 1.3835 now to get the blue angle that's in the third quadrant?
Take pi and add that?
Yes. So then you might say, oh, well, couldn't you have just taken 2 pi and subtracted that and you would have got that? Yes, you would have as well. So you have to try to make it so that you can clearly figure out how to get these answers. So 4.5251. So there is my A answer. Again, there's no way you could put this together. So my B answer is going to be the general solution, which is going to be 1.7580 plus every revolution, 2k pi, and then 4.5251 plus every revolution, where k is an element of the integers.